Hello everyone, welcoming you to Shorop Sir's classes. And today we are looking at the IES 2022 paper General Economics paper 1, and we are looking at question number 3 part A. Define the indirect utility function and derive the indirect utility function from the direct utility function. So you must be remembering that when we were talking of the consumer behavior and utility maximization objectives of the consumer, the utility function for, let's say, for example, what was the setup? The utility function was given by the level of the two goods that are consumed, right? So U is U of x1, x2, right? So the levels of consumption of the two goods determined what will be the utility obtained. And what was the budget constraint? It was M is equals to P1 x1 plus P2 x2, a standard two commodity framework. Now in this setup, what are the variables that we need to determine that the consumer chooses is the level of consumption of the two goods. And what are the parameters that the consumer cannot change at a given point in time? The prices of the two goods, which are market determined, and the money income, P1, P2, and M. Right? So this utility function depends upon the levels of quantities, right, that the consumer will obtain. Now, instead of the levels of the commodities, instead of x1, x2, if the utility function is defined in terms of the parameters of the model. That means parameters of the model, that is your P1, P2, and M, then we call it the indirect utility function. That means from x1, x2, we shift to the variables being P1, P2, and M. We call it the indirect utility function. This is the primary idea that I want to pitch. And then particularly, like, what exactly does this say? Indirect utility function basically captures the maximized value of utility. That means the maximum possible utility, possible utility achieved by a consumer, achieved by a consumer for a given price level and money income. Okay, so obviously one thing I think you must be in getting having an idea that the direct utility function is required to obtain the indirect utility function. The indirect utility function will be obtained from the utility maximization exercise. So what happens is that so what is the objective of a consumer? The objective is you will try to maximize the utility, which is a function of x1, x2, subject to the budget constraint, which is m equals to p1 x1 plus p2 x2. Correct? And we know that how we can optimize this. We can go for this direct Lagrangian. So the Lagrangian is set it up u of x1, x2 plus lambda times m minus p1 x1 minus p2 x2, where lambda is known as the Lagrange multiplier. Okay, so what do? You differentiate this with respect to the three variables x1, x2 and lambda. So what will you get? You will get del u by del x1 plus lambda times minus p1 and set it equals to 0. What is del u by del x1? Is basically the marginal utility from good 1, and that is equals to lambda p1. This is my equation 1. Del mu by del x2, so that will be del u by del x2 plus lambda times minus p2 is equals to 0. So mu2 is equals to lambda times p2, correct? And finally, if you differentiate this with respect to lambda, you basically get back the budget constraint. That means m equals to p1 x1 plus p2 x2. So using these three, we need to obtain the optimal x1 and x2, and we denote it as x1 star and x2 star. Okay, and we'll obtaining lambda star as well. And these are basically, you can understand that using these equations we will obtain, so there are three unknowns, which is x1, x2 and lambda, and there are three equations, so they can be easily obtainable. So these x1 star and x2 star are known as the Marshallian demands, right? So these are the Marshallian demand functions that you get by maximizing utility subject to a budget constraint. Marshallian demand functions. And Marshallian demand functions are basically depending on the parameters of the model. That is, x1 star is a function of p1, p2 and m, and x2 star is a function of p1, p2 and n. Therefore, so what is the what do we mean by the optimal demand? It's basically the best possible consumption bundle that the consumer can get given the budget constraint. So this is so consuming x1 star and x2 star gives him the highest level of utility that he can get. So this is basically, so if I'm substituting x1 star and x2 star, I'll be getting the highest level of utility. So I'll denoting it as u star. Okay, and note one thing, that x1 star is a function of p1, p2 and m, and x2 star is also a function of p1, p2 and m. That means the highest obtainable level of utility in turn depends upon these parameters p1, p2 and m, and this is what we call it as the indirect utility function. Indirect utility function, and we generally denote it as v of p1, p2 and m. So that is why the term mm, uh, maximum possible utility, because the moment you substitute the demand, that is giving you the highest level of utility that you can obtain given a budget constraint. So the indirect utility function gives you the maximum possible utility that you can obtain given in the price level and money income. So that is how we are going to derive the indirect utility function from the direct utility function, by simply performing the optimization exercise. So this is part A of the question. Now coming to part B, consider the indirect utility function as V equals to m square by 4 p1 p2, where notation have their usual meaning. Derive the demand functions for x1, x2. So by demand over here, we basically mean the Marshallian demands. Because remember one thing, that if you are required to find the Hicksian demand, they will explicitly mention that. Normal demand function is essentially meant by the Marshallian demand functions. So now coming to part B. V is given to be m square divided by 4 times P1 P2, and we need to obtain, basically by demand functions we mean x1 star and x2 star. This is what we need to obtain. So for obtaining that, we need to use what we call it as the Roy's identity. What does it say? It basically says that, let's say I define it for good one. That means the Marshallian demand for good one. So that is defined as minus of partial derivative of v with respect to p1 divided by partial derivative of v with respect to m. I'm not going into the proof of this thing, and once again, if you are interested in knowing the proof, do let us know in the comments. We will get over with a short video on this, explaining how the Roy's identity is obtained. For the timing, you can just take it as a result that you need to use to get to the demand functions. Okay, so let's obtain that. So what is the partial derivative of v with respect to p1? M square and other things remaining constant. So m square by 4p2 remaining put. This will be minus of 1 by p square. And what is del v by del m? It is basically the m will get differentiated, so that becomes 2m, and the rest will remain constant. So that is m divided by 2 times p1 p2. Okay, so what is x1 star? It is minus of the first term will go in the numerator, so m square divided by 4 times p1 p2 divided by m times 2 times p1 p2, and a minus we had over here. So 1 m will cancel out, p1 p2 p1 p2 cancels out, 2 times 2 will get cancelled out. So this was p1 square. So 1, sorry, there's a small mistake, let me rewrite this part. So the m square will remain, and over here we have p1 square. So 4 p1 square p2. p2 will cancel out, 1 will cancel out, and this will cancel out 2 times. So you basically have m by 2 p1. This is the optimal demand for x1. And similarly, what will be my x2 star? The denominator will remain intact, the numerator will be partial derivative of v with respect to p2, right? So del v by del p2 will be m square by 4 p1 out minus 1 by p2 square, and del v by del m will be 2m divided by 4 times p1 p2, so that is m divided by 2 times p1 p2. So x2 star is equals to minus of minus m square divided by 4 times p1 p2 square divided by m 2 times p1 p2. So 1 m will get cancelled out, 1 p1 will get cancelled out, 1 p2 will get cancelled out, this. So that is m by, so these are the optimal demands for x1 and x2. Now coming to the third part of the question. Consider the utility function and the budget equation of a consumer respectively given by the So a Cobb-Douglas utility function and a budget constraint, where notations have the usual meaning. We need to derive the expenditure function of the consumer. Okay, so let us write down the essential information and then we can start. U as a function of x1, x2 is simply a Cobb-Douglas, and the budget constraint is equals to p1 x1 plus p2 x2. So for calculating the expenditure function, we need to first obtain the Hicksian demand curves and then we'll replace them. So what's the expenditure function? It's the minimum expenditure that you need to incur to obtain a fixed level of utility. So what we are going to do, we will, let's say, fix u equals to u bar, and we'll try to see the minimum expenditure needed to obtain u bar. Okay, so what is expenditure? If you can just obtain, the expenditure is basically the amount that you will spend in consuming the two goods, right? So what is my objective? I'll try to minimize expenditure. That means E, which is equals to P1 x1 plus P2 x2, subject to U equals to U bar. Correct? So what do? We again set up the Lagrangian, which is P1 x1 plus P2 x2 plus mu times U bar minus U of x1 x2, where over here mu is the Lagrange multiplier. So that means over here we have a particular utility function which is given to us. So mu times u bar minus x1 x2. So we are going to differentiate this with respect to x1 and set it equals to 0. So p1 plus mu times minus x2 is equals to 0. That means p1 equals to mu times x2. Del pound del x2, setting it equals to 0. So that gives us p2 plus mu times minus x1 is equals to 0. So p2 equals to mu times x1. And finally, del pound del mu is equals to 0. So that gives us u bar minus x1 x2 is equals to 0. That means u bar is equals to x1 x2. So this is my equation 1, this is my equation 2, this is my equation 3. So now if you do 1 divided by 2, you'll get P1 by P2 equals to x2 by x1, or x2 is basically P1 by P2 times x1, and if you substitute that in 3, u bar equals to x1 into x2. So in place of x2 I put P1 by P2 times x1. So that basically gives me P1 by P2 times x1 square. So now as you have fixed the utility, so P2 by P1 times u bar is equals to x1 square. That means x1 is basically square root over P2 by P1 multiplied by U bar. So this is basically the Hicksian demand curve or the uncompensated demand curve. This is the Hicksian demand curve. And from this expression right over here, therefore the Hicksian demand curve for good 2 will be P1 by P2 times x1u. So that is P1 by P2. There has been a small mistake. This will be P1 into square root over P2 by P1 times U bar. So that is basically square root over P1 by P2 times U bar. So what is the expenditure function? It's E is equals to P1 x1u plus P2 x2u, the minimum expenditure that is required. So if you substitute the values that you have got, so E is basically x1u is root over P2 by P1 times U bar plus P2 times root over P1 by P2 times U bar. So that is 2 times square root over P1 P2 U bar. This is your expenditure function that we were required to obtain. So this is the answer to part C. Thank you.